How to build a Blackgates Sweet Pea 5-inch gauge locomotive. This is part 48. Remaking the slide valve drive blocks using a non-ferrous metal that will not rust and remain a free fit in the slide valve slots. You may be thinking, why does the drive block need to be quite a loose fit in the valve itself? It doesn't need to be too loose, but if it's made from a ferrous metal that rusts, you need some clearance. And also it's not quite as important on a horizontal steam engine, but on a vertical steam engine, if you get a rust problem with the drive block or the valve is too tight a fit on the valve rod, then it will lift the valve off the port and the engine just won't work. It is only steam pressure that holds the slide valves against the ports. It's normal practice to thread the drive block, that way you can adjust the position of it by rotating the valve rod, but in this case it doesn't work like that. As you can see in this clip, there are two brass collared nuts. This is not a bad idea. These nuts will securely hold the drive block in a fixed position. I'm going to make a couple of new drive blocks, but I'm going to use brass rather than mild steel. By the look of this original steel drive block, it was made using a 4-jaw chuck. Those are chuck jaw marks on the steel. It's a good idea to use packings to stop this from happening when you're doing 4-jaw chuck work. I looked in my scrap box and found a block of brass. Being a bit thick, it was not ideal. I don't mean me being a bit thick, the brass is a bit thick. These days I've decided that a Sharpie felt tip pen is quicker and easier than marking out fluid, and it does the same job. In this clip I'm showing the principle. I mark the brass with the Sharpie felt tip pen and then I scratch away some of the felt tip pen mark, revealing a nice, clear, shiny line. These drive blocks are precision parts. If you have a look at the existing steel drive block, you will see that the hole is right in the centre. There isn't much tolerance and I need to duplicate that on the piece of brass. This piece of brass really is a bit thick. I'm making work for myself. What I am going to do with this piece of brass is saw it in half, and for this I'm using my bandsaw with an extremely blunt blade. I'm pushing the piece of brass against the blade using a small mahogany plank, and I'm having to move it about to make sure that the blade cuts straight, and it really didn't even cut straight after all that. I do know that this is not a good way to do it, but I'm showing this way because beginners would possibly do it this way, and it's not the best thing to do. The reason I make these videos is to show people how to do certain jobs, and that includes beginners as well as intermediates. If you're an expert machinist, you really shouldn't be watching my videos. I have to admit that machining pieces of metal is not one of my favourite pastimes. Once again, instead of using marking out fluid, which is very messy and takes a while to dry, I'm using a felt tip pen again. Before I cut this piece of brass, I'm going to change the blade on my old bandsaw. I'll do it in high speed so it's not too tedious. The knob at the top of the bandsaw moves the wheel up and down so you can tension the blade. Once I remove the blade, I folded it up. This makes it easier to throw away. Then I undid the ties on the new blade. You have to be very careful though when you get to the end of this and it springs out into one long blade. But don't forget that unlike the previous blade, this one is sharp. I'd just like to mention that at the moment I've turned the mains off to this machine, so I can't accidentally start it when I'm fitting the blade. Once the new blade was fitted around all three of the wheels, I used the top knob to tension it. Then I aligned the blade with the knob behind the machine. The last job is to secure the cover in place using these special quarter-turn screws. With a new sharp blade fitted, it's much easier to cut the piece of brass accurately. Notice that I'm using a piece of wood to push the small brass block through the blade because I need all my fingers for other jobs. One more time with the marking out fluid or Sharpie pen, and then scribe a line on it because it's time to use the milling machine to cut these blocks to the correct size. And now for a quick top tip. Whenever I fit metal blocks into the machine vise on the milling machine, I bash them with a soft hammer. I don't hit them too hard, just enough to seat them in the machine vise. Most of these milling operations are running at a much faster speed than normal. My old milling machine is a Nairok, which is Korean spelt backwards, and it's not the best milling machine out there. I use it for two reasons. One being I've built lots of locomotives and repaired lots of things using it, and it works. I'd like a Bridgeport milling machine. I think they're really good. A friend of mine has a Walco Major, and that seems pretty good too. But I really don't want one with a DRO. I'm not too keen at looking at numbers all the time. Numbers have never been my strong point. Years ago, when I took my O-level exams, they weren't called GCSEs then, they were called O-levels, I drew a really good picture of a BSA 650cc motorcycle across my maths paper, and in retrospect I think the only marks I got in the exam was for writing my name on the exam paper. I'm okay with language, but not too good with numbers. This is precision drilling. I'm using a centre drill in the drill chuck, and I'm making minute adjustments so that it's in the middle. How do I know it's in the middle? Well, I can see it with my eye. My marking out is terrible, and I never trust it. I always use my eye to get the holes in the right place, and 99% of the time it works fine. This being one of those times. And how do I do this? It is not witchcraft, it's just the calibrated eye thing. The more you do a job, the better you get at it. This is my drilling machine, and it's horrendous. It's always been horrendous. I really should buy a new one of these, but I sort of live with it. And just because the capacitor in the motor's gone and I have to start it by hand, and the fact that the column wobbles about as I wind the handle, I can still drill holes in pieces of metal accurately enough. After drilling holes in both of the blocks, I clean them up on a piece of 400 grade wet-to-dry sandpaper. Recently I bought a whetstone, but for some reason I keep forgetting to bring it up to the main workshop because it needs to live in here. If you look carefully, these holes are in precisely the right position. I don't know why the design didn't call for thicker pieces of brass, but anyway, I've made this to the drawing, just about. It's fractionally longer. The slots in these valves have been cut slightly different, so there's a tolerance to work to. I don't want a tight fit. It has to do what you see here, be able to move up and down, not really a rattle fit, but a bit of movement. Don't forget, when the engine is in service, these will be coated in steam oil, which will take up any gap anyway. But the good thing is they are not going to rust and stick in the gaps in the valves. Here I'm assembling the other one, and now I'm putting them both together. Because they're made of a non-ferrous metal, they are not going to go rusty, and they are not going to stick in the gaps of the valves. I think this is an improvement on the original design. And having said that, it's time for me to go. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.